really my goal for this session is to get the audience an idea about what are the trade-offs between using SLMs, which stands for small language model, and the LLMs, the large language models, and to get an idea of what are the pros and cons, the trade-offs, and what are some of the use cases where you could be relevant to use either one of these technologies. So just to get started, I think it's not surprising that different people would have different definitions for what is an SLM. So what do you think, in your view, what would be an SLM, and how do you relate this to maybe energy concerns and sustainability?
Sure, I'll take that one. When we think of an SLM versus an LLM, we can think of the SLM as being a form of agentic AI. It's one form of that, so it's laser focused. So as opposed to scouring the entire internet and millions and billions and millions of data points, we're using the SLM, which is specifically trained on the data points that we've given it. The rough cutoff is around 1 billion, 2 billion for that. So if you think of it as an SLM, if you have to put a Band-Aid onto a person, you wouldn't hire a neurosurgeon to do that, right? It would be specific to that particular task. So anything above that is overkill. So that's how I would define the difference between an SLM and an LLM. And also we have to look at the amount of kilowatts of usage as well. So when we're thinking about sustainability and we're thinking about the data center usage, obviously the SLM is going to have a much less consumption when it comes to the data center usage. So we're also thinking about sustainability as well.
All right, thank you. Anybody else?
I think you hit the nail on the head. It's all about purpose-built models that are specific for those industries, for those use cases, for whatever the purpose is. And the benefit is, let's be honest, it could be a 3 to 5x more expensive token or cost to query that model when it's a big one as opposed to a small one. And also thinking about the horsepower, the amount of energy that's used, the amount of GPUs required, it can be an exponential increase depending on the size of those models. So look at some of the biggest ones, for example, and these are thousands and thousands and thousands of the world's largest GPU processors burning hundreds of kilowatts per second just to execute something simple like, hey, what's the weather today?
Another thing we can touch on as well is data sovereignty, right? So we have data sovereignty within borders, UAE, but also data sovereignty within a company as well. So if we have an SLM, we can have instead of pushing it out to the cloud, we can have our own smaller in-house data center, if you will, something along those lines, that just processes those AI points, and now it's remained in-house. So you don't have this issue where your data is being pushed out to the cloud. You've kept it in-house. You've maintained that data sovereignty.
Yes, Samit, what do you think?
See, I am working on this model from last 7-8 years. So I started with SLMs. Basically, I was trying to find out what is different and the difference between SLMs and LLMs. Nowadays, there are a lot of generative AI models there, like 1 billion, 3 billion, 8 billion and more, right? So I wanted to find out what is that benchmark, right? You say, okay, after 3 billion, this is large language model, right? But still, that is still confusing. People are still trying to figure out. But for me, for my definition, right? After working for years, I was working on the early models like bird type models, fish transformer models, right? Those are SLMs. The inference, when you do inference on those models, you can do it on your CPUs. But when you use LLMs, right, you'll be needing GPUs to do inference because you stream lots of data, right? And right now what I'm seeing, the biggest challenge of agentic AI system is, or any kind of AI system we are building nowadays, is the price of the system, cost of the system. So recently a report came from Gartner saying 40% of agentic AI use cases will get closed by 2027. Why? Because it will be too costly. So I work in voice AI. So in voice AI, calling one person, right? It costs around 3 rupees in India. But now, let's say if you implement an agent there, it costs 15 rupees. Just think about it, right? Then why do you need AI agent then, right? So the question is that
hopefully the cost will go up for Indian employees as well. Okay, so guys, what do you think is one of the relevant use cases where SLMs can play an important role? And maybe you can talk about from your own experience and what you're building. Who wants to go ahead?
I can
Please,
take
Ben.
this one first, and then I'm sure you've got some great examples as well from your different area. Because it's interesting, we're in pretty complementary areas, which is nice. And so I'm focused on energy, and Atelic is actually very much focused on energy industry and how we approach that. And so for me, from an SLM perspective, it's about bounded, auditable, and consequences, and being able to understand exactly what the output is going to be and when. And think about it this way, a pump, a piston, a turbine, anything in this industry, it's very confined because you actually know how many ways it can fail before it even does, right? So you don't necessarily need the gigantic models, the huge LLMs, the unbounded things in order to figure that out. So when I think about it, I think about simple things like taking SCADA data or taking IoT data from the edge, tagging it directly and making that ontology immediate to get value from the agents and to get value from the other parts of that enterprise. Because the goal is actually reaching a level of autonomy using AI and doing it as cheaply as possible to achieve the use case that's necessary.
Yeah, I can piggyback that. I'll give an example. So within Digit Alchemy, the platform that I built, we look at BIM models. So BIM models is something that we train on SLMs. So a big difference would be my SLMs are trained on LOD, which means level of detail. I don't know if anybody has a construction background, but it means level of detail. Now, level of detail, because I've trained that SLM, it knows level of detail means level of detail. However, if I push LOD 400 into an LLM, it could mean Legion of Doom, it could mean multiple things, right? Because it doesn't know. So it's scouring the entire internet and it's looking for that acronym. So it's going to hallucinate as well. So whenever you move from an SLM to an LLM, the likelihood of hallucinations when you're dealing with a very specific task in a very specific industry, such as BIM models, which run LOD 100, 200, 300, I'm training it on Kobe, I'm training it on IFC specifically, so there's very little chance for any hallucinations. And that's one of the best things that you'll get out of an SLM.
See, in my view, LLMs are very good at reasoning, and sometimes we need that, right? And the main thing we can play with is number of tokens we are consuming. So what we can do, we can actually plan our task using LLMs, but we can use SLM for those smaller tasks. So these SLMs work on CPUs, and LLMs will consume very less token, will plan it, and now when we do those smaller tasks, it will not hallucinate because it is just trained on those specific tasks. So that's how I use it.
If I can add this, Sumit's statement there, I'd actually argue for anything industry, anything heavy industry, it should almost be like 90% SLM usage over LLM usage. Because of the cost, because of the energy consumption, and also, like you guys already mentioned, because of the potential for drift and hallucinations that can come from having such a big unbounded environment. So.
Okay, great. So I think you already gave some ideas of when you should choose an SLM over an LLM, but just to like synthesize, what would be like your rule of thumb of when would you go for one over the other? How would you reason about doing this selection?
I can talk about it. So let's say you want to do some kind of classification, right? You want to classify between, like let's say you're doing claim, you want to reject something or accept something, right? So you already know about those data. If this data will get it, then this will be a rejection or acceptance, right? So and now there are other parameters as well. So you use LLM to plan, okay, what are the features? And now you can use smaller LLMs there or a small language model and take this decision there. So this could be one of the cases.
Yeah, I can touch on that as well. Within Digital Alchemy, we also put forth digital transformation roadmaps. So we can use LLM. So what we used LLM for was to scrape across the internet, across 66 countries, to get the governance and the regulations associated with digital twins, smart cities, IoT complexity, anything that has to do with that form of digital transformation. whether that be from a developer perspective, from a government perspective. Then when we drill down into an SLM, we say within this particular district, we are looking for digital transformation for this particular process. For that, you're going to use the SLM because now you've already pulled all the information from the 66 countries. However, if this digital transformation is taking place within Abu Dhabi, I'm specific to the 17 or 18 regulations that I have. So I don't want to scrape across the 66 countries again. I drill down into the SLM. So for the complex reasoning, I've used the LLM, and then I'm drilling down into the SLM to try to get to a very precise digital transformation roadmap via RIBA.
I'd argue it gets back to the basics. 3 C's, guys: control, cost, consequences. So when you have to have full control, you need to know why that answer came out and why it's there, and you need to know this is the lowest possible price, and I need to be able to, if something goes wrong, things go boom, or somebody could get hurt, or the business process will fail, which hurts my business. That is when you need to look at more specific, focused, fine-tuned models that are for your purpose. So SLMs immediately fit for that. When it's wide, it's unbounded, you don't know what questions will come in. It could be just a customer on your website asking anything in the world. Maybe that's a time when you'd want to look at the bigger ones. But I actually think the industry's heading a lot more towards SLMs overall and LLMs as the backup.
Okay, great, thank you. So now let's get a little bit more technical, since you already mentioned about fine-tuning. So how do you see the trade-offs between the SLMs and LLMs where fine-tuning comes in? So what do you observe there?
So I'll give one example. So I work for a voice AI company. Okay. So when you want to run a voice AI, you need text-to-speech model, you need a speech-to-text model, and you need one master LLM, which is the actual brain, right? And you also need a dialogue. And in general, like most of the companies operating, they use 5 different SaaS products for this purpose. And just think about it, you use 5 different SaaS products, how will be the cost? And if one of those fails in production, then what will happen? So for this, for handling this, we actually work on fine-tuning our own model. And again, there are lots of things like if you fine-tune, it doesn't mean you're fine-tuning from base. There is a concept called transfer learning. You take a model, pre-built model, and now you take additional data and just do transfer learning on top of that. And I've seen like it performs really well, right? So I was able to train our own TDS, like text-to-speech model, even fine-tuned our own LLM on domain-specific data. And we already have speech-to-text models that can be directly used. So, and what we have seen, our price went down by 100% by owning the stack. If you call like 100K call a month, it is 100% lesser than the price when you're using 5 different SaaS. So that's how it adds value.
Anybody else? Or the fine-tuning?
Yeah, I think it's all about the specificity of what you're actually using the use case against. So in what we're looking at is very specific, machines and turbines and things like that have to have very specific parameters against them. Think about it this way, all the LLMs are trained on publicly available, mass-produced Reddit crap, to be honest, and the reality is that because of that, they're never going to be specific enough for these heavy machinery type of situations. So I think it's very simple. When do you want to fine-tune? Whenever you have a very specific problem you're trying to solve. I think when you want to go generic, go big LLMs, whatever, you pay the cost for it, but I don't think it's always necessary. I think the only other thing was, if you think about it from an edge perspective, there's definitely some good opportunities to use those SLMs, very highly tuned, highly trained, not highly trained, but highly fine-tuned in order to match all the potential situations that edge will see.
I want to add.
Sorry, I can touch on that as well, just from, again, coming from a construction background or coming from a delivery background. There's a lot of video generators now, NV3, some of these other ones, they're really, really good. However, in the industry that I work in, and for digital alchemy, what we're trying to do is generate an image, but that image is auditable to come back to an actual BIM model. So if you have these really pretty pictures on YouTube and you see they're generating a house or a villa or a district, when you actually peel back one layer, it's only for visualization. So you can't take that and put it into an actual BIM model, IFC, Kobe, where the door is a door and a window is a window, right? So you have that ontology. So what we train, that's why it's so important that we get away from it's nice to do the video generation, right? But it's more practical when the video generation, when you can peel back a layer with actionable intelligence. So what can you use that for after the fact? You give that to a BIM person. Can they then evaluate that and push it for something that can actually be built? Visioning is nice, but actionable intelligence is much more valuable to any industry.
I want to add on top of Ben's point, like earlier you were discussing about domain-specific models, right? So when we talk about the LLMs today, we actually don't know on which data it is trained on. Whether the data went inside is correct or not. Because they just pulled data from internet and just trained it, right? So right now when you fine-tune it, it just answers from your data, your company data. And you own it as well. That is another thing.
Absolutely. And another thing is that probably if you're training and fine-tuning an SLM, that is going to take only like a few hours of GPU time. While if you're going to do it with an LLM, there's going to be days of GPU time training. And as well, the size of the data that you need for the LLM is also much higher. So you've already mentioned something about hallucination, but since these models are basically non-deterministic, how do you deal, and have you seen this in practice, where things go off the rail with hallucinations, and what mitigation strategies did you try to apply?
Well, I look at it very simply put, it's about guardrails. It's about properly applying those guardrails. Sometimes that can be a situation where you're using one model to test the other, to validate the results of that model. So I love using SLMs, for example, to help double check what's coming out of the big boys. But to be honest, I think it also depends, because I wouldn't use an LLM to make a decision on, will this pump fail, right? Or, you know, when I run a digital twin, I need to use a physics-induced neural network to actually validate that against the machine learning model that knows that machine extremely inside and out. It's kind of how they're doing with BIM. It's actually the same thing for us, but looking at it from the physics side, because physics is immutable, right? That's not going to change depending on, you know, what data was let in there. No, it's based on the model that's correct from the start. So when it's something that's important like that, like the pump could go and now the whole factory goes down, or the pump could go and now the oil platform has a big problem out in the North Sea, guess what? We need to do a double, triple check on it. So, and that's where the guardrails come into effect.
Yeah, I'll be very concise and brief with my answer. Human in the loop. It's as simple as that. Whatever your output is, have a subject matter expert at the beginning of that process and at the end of that process. They can come into the process boring, but usually it's not necessary. But never get rid of that subject matter expert that's going to validate whatever that output was. Keep the human in the loop. Don't be fully dependent on the SLM or the LLM or the agentic AI. No matter how well trained it is, must keep the human in the loop.
I agree to this point. Like, you know, so there are lots of concepts nowadays, like LLM as a judge. So I'm a little against that, because you are building AI and again putting another AI to validate it, right? There should be some human in the loop. By some, you know, you have to measure the confidence and get into human in the loop. But when we talk about hallucination itself, right? All of us, like seeing on LinkedIn here and there, people are talking a lot about RAG. And RAG is, when you use RAG, it just chunks the text from anywhere in the sentence. There, when, you know, models start getting hallucinated, right? And again, when you actually move to a small language model, fine-tuning it, you can actually reduce it up to much extent, right? That's how I see this going in. But again, there are lots of the hallucination led to lots of AI safety aspects in past. Lots of people also filed lawsuits against these models, And we can see day by day the current models are kind of getting better by putting lots of guardrails. Guardrails is one way, and again second is another.
Can I be provocative for a second?
Absolutely.
I hope that's all right, guys. I'm just having a little fun today. I'd actually argue that the way that we're headed as a human species and the way we're headed as the industries in general is actually we're going to take the human out of the loop at some point, right? I actually agree there's certain circumstances that there's always that double check, that kill switch, that guy, you can push the button and stop the process, stop the agent, whatever it happens to be. But I actually would argue that that's going to be less than 10% of the times moving forward. So the question is, how do you get to a point where you can actually trust your AI, how you can trust the agent that it is making the right decision? And it's about the auditability, it's about the traceability, it's about knowing they made it this way for this reason, and here's the audit trail, here's how I can go back and track it down if there is a problem later to validate that. Because what's going to happen over the next 2 to 3 years, by the way, is that as that improves, as the auditability is getting better and better, you're going to start to realize, wait a minute, I don't actually have to do these low-level processes anymore, having the guy double-check it, because I know it works. And then you start to move up the stack a little bit more to, well, maybe it's a little bit more critical, maybe it's a little bit more serious, maybe it's not the $1 million trade for the stock trading platform or the button that can prevent the thing from blowing up on the factory floor. But I think it's going to keep easing up and moving up to that direction. And let's be honest, I think that it should. But we have to be able to track and trace and know why. And that's the problem. And especially if we get back to the LLM discussion, we can't know why because of how much data is there, how it was trained, how much junk is it based on, right? That's it.
Let me piggyback that as well, because I like that frame of that conversation, right? So we all know that we use ChatGPT, Anthropic, and these. We all know that there's artificial superintelligence that's a bit off, but it's coming. Now, there's another form called neuromorphic AI, which is a bit further out, sitting in MIT and a few of these other places as well. Neuromorphic AI will begin to blur that line. Neuromorphic AI is being developed by neuroscientists, not by computational engineers. So it's not based on predictability, it's not based on pattern analysis, it's based on the synapses in our brain. And that is really going to begin to blur that line between human thinking and AI thinking. When you get to neuromorphic AI, it's going to be a scary time to be honest, because compassion.
Or exciting.
Yeah, or exciting. Yeah, but compassion will kick in. The way that we reason will kick in, and the other thing that will kick in, if you're ever interested in an old movie called 2001: The Space Odyssey. This movie came out 25, maybe 30 years ago, and there was an AI agent called Hal. And what Hal did, he's neuromorphic AI, just wasn't realized at that time because the AI has been around for many, many years. But what that neuromorphic AI did was the owner of this, it was on a spaceship, and the owner of the spaceship commanded the AI to open the door. Hal responded with, I'm not going to open the door.
Spoiler alert.
Yeah. I'm not going to open the door. I've learned how to read lips, and I read your lips. And when you were talking to the other person, you told them you wanted to open the door so that you could shut me off. I don't want to be shut off, so I'm not going to open the door. That is not far from where we're off, and it's either scary or it's exciting or whatever, but I guarantee when we hit that, the line will be blurred between us and the machines.
Okay, let's bring it all back to the sustainability of it. So what do you think about the UAE landscape in terms of like AI adoption? Is it more about adoption, or they're really like focusing on like sustainability and reliability of these models? Where are we at in this timeline?
So I think, well, we have the 2050, right? So we have these initiatives. We also have UAE 2031 AI that's being set up. We also have a mandate that any government, semi-government entities have to have a chief AI officer, which is something that's not implemented in any other country. So the UAE takes it very seriously, and this is why the UAE is a leader. And big shout out to the leadership of the country, putting forth all of these regulations and frameworks for this to be successful. One of the things that we try to do as at Digital Alchemy is we take an individual IoT sensor. So let's say it's a smart irrigation sensor. We map that sensor specifically to LEED and what those credits look like. We map it specifically to Estidama as well, so that someone can understand if they're going to implement that sensor, what impact is that on sustainability in general for a company? Are they getting the LEED credits? Are they getting the Estidama Pearl that they want to get? Are they reducing their carbon footprint? Are they hitting UN SDG? So for every individual sensor, we've tried to think of all of these sustainability touch points to make sure that there's a full understanding that you're not just putting a sensor in the ground, or you're not just putting a sensor on the wall. Understand the cascading effects and how it's impacting Mother Earth in general.
I think we're extremely lucky to be here in the UAE, to be honest, because I mean, it's such a partnership between what's happening in the public sector, what's happening in the private sector, that it's actually going to leapfrog. I do feel like overall it's a few years behind what's coming out of, let's say Silicon Valley and maybe some of the earlier offshoots there in Europe. But it's going to actually way extend it. And look at it just for example, like Stargate. Look at it for example, the large AI data centers that are being built right here in Abu Dhabi. It's absolutely amazing. And the amount of capacity that's on order today, I've heard about it, that only one or two of the projects is over 5 gigawatts by itself. Which, if you think about it, all of OpenAI that could be here, all of Microsoft Azure, all of the federal government is going to be less than 1 gigawatt of that consumption, right? Which is going to make this an amazing hub for AI in the next 2 to 3 years. Why? Because it's simple. Supply and demand. When you have an oversupply and you have the processing capability and you have the ability to do this, the price is going to come down. So I think we're right at the center of the storm, and I think this is the place to be, because if you're going to innovate and you're going to grow an AI business, or you're going to focus on AI use cases, this is where you want to do that.
Yeah, so I worked in AI security for like 1.5 years, right? So when we talk about AI, it's like next generation of AI, like LLMs, right? So we're talking about it from last 2.5 years, right? But when I was going and talking about AI security and governance, I saw like people are jumping into AI. But when I went to government entities and many other places, they're first starting off with governance and security first. So everyone is very much aware here. So okay, you do innovation, but do responsible innovation. Whether we talk about sustainability, security, or governance, right? So everything is in the place from beginning, but which I didn't see in other part of the world.
That's amazing. So one last question before we wrap it up. Looking ahead, what do you think in the next years is going to be more of a centralized LLMs landscape, or people are going to go into more democratized, using their own SLMs for different startups, or is it just going to be a hybrid of those? Where do you see things going?
I think it's definitely headed down the hybrid path, and the reason is that I think we're going to see an explosion of very specific SLMs for specific problems, and specific types of machinery or whatever it happens to be. But then you're still going to need the big ones to help for those more generic questions, more generic problems, etc.
So it will be all about how we play with the tokens. So right now we have to play responsibly. So let's say in ChatGPT, if you ask some questions, right? That takes 5x more electricity than searching on internet. So now whenever some token is going inside my LLM, we have to think, okay, am I going to answer from my LLM? Or we can use some smart memory as well. Like if they're saying, hi, how are you? I'm good. We don't need LLM for that, right? And there are many other questions. For that we don't need LLM. So we have to actually decide when we actually need LLM. Then we send those queries there, get the answer, done. Use as less as token you can.
I also think one of the main drivers of that is going to be data sovereignty as well. If you think about one thing we do in Digital Alchemy, and a lot of things when we develop is brand identity, right? So if we're thinking about property developers, if we're thinking about any particular type of developer, the brand identity is very important, right? So you have your major developers in UAE, and if you're pulling in data from one, they definitely do not want their data mixing with the other one. That's the data sovereignty of it, right? Not to mention, when you get into smart cities, when you get into IoT sensors, you're getting into data privacy, impact assessments, and PII. Most of that information cannot leave the borders of UAE, and definitely when you get into GDPR. So I came from Denmark. I worked for Facebook for 4 years in Denmark, and before that, I worked for Google in Asia Pacific as well. So GDPR over there, data sovereignty for sure. So these are the kind of things that are going to govern those SLMs as well as moving away from the LLMs. That data sovereignty is going to be very, very important if you're helping a corporate entity build their brand identity, or if you're trying to understand the overall texture, contours, or the feel of the brand. That is particular to that particular entity, and they don't want that shared with another entity. They own that. That's their intellectual property, right? So I think that's going to be driving the SLMs as well.
Great, thank you very much, guys. I think we're up for time. I hope you got a lot of insightful ideas, and yeah, it was great to have you on the panel. Thank you.
No, thanks for having us.